So I just want to take a little time to go over how to read these chemical formulas with all these numbers in it, how to figure out what number belongs to what element, how many elements there are in each of these. So let's go with this first set right here, the 2C3H6O2. And we know this is all one thing because it's separated by this plus sign. There's a plus and then the magnesium hydroxide over here. So we know this is all one thing because it's all on one side of the plus sign. So we have the number 2 and then C with a little tiny 3 after it, H with a little tiny 6 after it, and O with a little tiny 2 after it. Okay, so when we're dealing with these little small numbers, the 3 after the C, the 6 after the H, and the 2 after the O, these small tiny numbers apply to whatever is in front of them. So this 3 applies to the carbons. So 3 carbons. The 6 applies to the hydrogens, 6 hydrogens, and this 2 applies to the oxygens, so 2 oxygens. But then you have this big 2 in front of this whole long thing, this C3H6O2. So what this is saying is that C3H6O2 is one molecule, is all one thing. So if you want to think about it, here's a person and he's wearing a little t-shirt that says C3H6O2. So here is one person who is C3H6O2. So this is all one thing. This is one molecule. But then we have this 2 in front of the whole thing, this big 2. So that means that there are 2 of these guys. There's 2 of these guys. So that means there's going to be another guy who is also C3H6O2. So in order to find out how many of each element there are in this, we have to add these all together. So there are, in the first guy, there's 3 C's, and in the second guy, there's 3 C's. So 3 C's, 3 carbons, plus another 3 carbons equals 6 carbons, or you could write it C6, same thing. So there's going to be 6 carbons. Now, there are, for the hydrogens, there are 6 hydrogens in this molecule, but there are 2 of the molecule. So that means there's 6 on this guy's t-shirt and 6 hydrogens on this guy's t-shirt. So altogether, that's going to be 12 hydrogens. So there's 12 hydrogens total. And then for the oxygens, there's 2 oxygens in this one molecule, but there's 2 molecules. There's 2 C3H6O2s. So if there's 2 oxygens in the molecule, but there's 2 molecules, then there's this guy's got 2 oxygens on his t-shirt, and this guy's got 2 oxygens on his t-shirt. So that makes a total of 4 oxygens. So this is how much is total in 2 C3H6O2. So to look at this a different way, The big number 2 is how many molecules there are. What is the molecule we're talking about? The molecule we're talking about is C3H6O2. So we could put this in parentheses to show that it is all one thing. This is one molecule. And this 2 means how many of the molecule there is. And this is the molecule. And then these little tiny numbers after each individual element, that is how many each individual element there are. So there's 3 carbons, there's 6 hydrogens, there's 2 oxygens in each molecule. And that's in one of the molecules. But as we said, it isn't one molecule, it's 2 molecules. So if you just take this 2 and multiply it by each one of these, it's going to give you the total number of that element. So 2 times 3 carbons is going to be 6 carbons. 2 times 6 hydrogens is going to be 12 hydrogens. And 2 times 2 oxygens is going to be 4 oxygens. So this is going to be the total of 2 molecules of C3H6O2. Now let's look at the second molecule in the formula, magnesium dihydroxide. So this whole thing is magnesium, and then we have a parentheses, OH, and then after the parentheses we have the little bitty number 2. So what does that mean? First of all, this is going to be all one thing, one molecule. And you notice there's no number in front of this molecule. Like up here, when we did the other one, there was the number 2 in front of C3H6O2. So that means there are 2 molecules of C3H6O2. But there's no number in front of this magnesium dihydroxide. So if there's no number, we're just going to automatically assume that that's a 1. So we just don't write the 1 because it takes too long. So there's going to be 1 molecule of this magnesium and the OH2. Now what about this little 2 after the OH in parentheses? Whenever you have something in parentheses, you take this all together. And this 2 on the outside of the parentheses is going to apply to everything that's inside of this parentheses. So you're going to end up having O2 and H2. You're going to have 2 of each of these because there's 2 OHs. So there's an OH and another OH. 2 of them. So if you add those together, that's going to be O2H2. The 2 does not apply to the magnesium because the magnesium is outside of the parentheses. The 2 after the parentheses only applies to what's inside of the parentheses. Now there's no little number after the magnesium. So if there's no number written after the magnesium, then we're just going to assume that is a 1. So there's going to be 1 magnesium, 2 oxygens, and 2 hydrogens. So magnesium is going to be 1, and there's going to be 2 oxygens and 2 hydrogens in Mg parentheses OH2. Now let's look at the the compound or the molecule or, the chemical after the yield arrow, there's two of them. There's this one, and then there's a plus sign separating out the two H2Os over here. So these are each individual things. So let's start with this magnesium and then parentheses C3H5O2 and then close parentheses, and then there's a little 2 after that. So if this is all one thing, then we look to see if there's a big number at the beginning. If there's a big number at the beginning, that's going to apply to this whole thing. Now there's not a number there, so we're going to assume that this is 1. So there's one MgC3H5O2. There's one molecule or one compound of this. So now we're going to look at the magnesium, the Mg. Now there's no little number after the Mg, so we can assume that that means there's only one magnesium. And then we have this parentheses again. And remember, the parentheses separates this out into one thing. This is going to be one unit itself. And there's this little number 2 after the parentheses. So that means there are two C3H5O2s. So you could actually take this 2, you could take this 2, and you could actually write it as a big 2 in front of the C3H5O2. This is saying the exact same thing. There's two C3H5O2s. So if they're inside the parentheses, this little 3 only applies to what's right in front of it, this carbons. This little 5 only applies to the hydrogens, and this little 2 only applies to the oxygens. So there are 3 carbons, 5 hydrogens, and 2 oxygens. But then in the parentheses, but then there's 2 of them total. So that means there's one C3H5O2 and another C3H5O2. There's 2 of them. So all you do is you add these, you can add these together. So 3 carbons and 3 carbons make 6 carbons. 5 hydrogens and 5 hydrogens make 10 hydrogens. And 2 oxygens and 2 oxygens make 4 oxygens. So in parentheses, C3H5O2 with a little 2 after the parentheses is the exact same thing as C6H10O4. But now we have to rejoin this back with the magnesium. We got to take it home. So now we have one magnesium and we have 6 carbons, 10 hydrogens, and 4 oxygens altogether. Now let's look at the 2 H2O at the very end here. There's 2 H2Os. So this big 2 means there's 2 of this whole thing. There's 2 of them. There's one H2O and there's 2 H2Os. So there's 2 H2Os. So if you add these together, 2 H's plus 2 H's is 4 H's, and 1 oxygen plus 1 oxygen is 2 oxygens. So in 2 H2O, there's a total of 4 hydrogens and 2 oxygens. You can also, if you don't want to add them together, you can multiply. You can take this big 2 and multiply it by these little numbers and get the same result. So if you take 2 times 2 H's, that's going to be 4 H's. And 2 times 1 O is going to be 2 O's. So see, this is the same thing. 4 H's and 2 O's. So when you're balancing equations, you want to draw a line right through the middle of the yield arrow. So this on the left is going to be the before picture. These are going to be the elements, how the elements are organized at the beginning. And then everything on the right of the yield arrow, of the right of the line, is going to be your after picture. This is going to be your products that are made through this reaction. This is going to be your results on the right side. So when you're balancing equations, you need to add up how many each element is on the left side and how many each element is on the right side. So let's start with this carbon, C. So let's put a C over here and a C over here for the right side. And we need to figure out how many carbons are on each side of this yield arrow. How many carbons are in the before picture and how many carbons are in the after picture. So the only place carbon is in the before picture is right here at the beginning, where it says 2C3H6O2. So this 3 means there's 3 carbons in the molecule, but this 2 means that there's 2 molecules of this. So if you take 2 times 3, you end up getting 6, so there's 6 carbons. And then let's go over to the right side of the arrow of where the after is. And the only place there's carbons on the right side is right here. And there is a C3, so that means there's 3 carbons in this little molecule. But this little is in the parentheses, and after the parentheses there's a 2. So that means there's 2 of whatever is in the parentheses. So if you take the 2 times 3, you'll end up getting 6 carbons, and there's 6 over here. Now, when we balance equations, I always say save your hose for last. So don't do hydrogen and don't do oxygen yet. Let's skip over those, and let's go to the next element that's not a hydrogen or an oxygen, which is magnesium. So this magnesium right here, there's no number in front of it, so we're going to assume that's a 1. And there's no little number after it, so we're going to assume that's a 1. So that means there's only 1 magnesium over here on the left side. Now over here on the right side, let's look at this. Here's the only place that we see magnesium. There's no number in front of it, so that means 1. There's no little number after it, so that means 1. So there's only 1 magnesium. All right, now we've gone through the carbons and the magnesiums. Now all we have left are the hydrogens and the oxygens. So let's look at hydrogen first. Do hydrogen next to last, and then do oxygen last. So let's look at the hydrogens. And hydrogen appears twice in the before picture. There's a hydrogens over here, and there are hydrogens over here. So let's look at the left one. There are 6 hydrogens in this C3H6O2, but there are 2 total C3H6O2s. There's 2 of these. So we could even put these in parentheses and treat this like one thing. And there's 2 C3H6O2s. So if there's 6 hydrogens, but there's 2 sets, then 2 times 6 is 12. So that means there's 12 hydrogens over here. But we're not finished because we have to go over to the hydrogens over here as well. And this hydrogen is in a parentheses, and after the parentheses, there's number 2. So that means there's 2 times whatever is in the parentheses. So we take this 2 times the 1 hydrogen that's in here, so that makes 2 hydrogens. So now we have 12 hydrogens over here, 2 hydrogens over here. If you add them together, you get 14 hydrogens. Now let's look over at the right side. There are hydrogens in this parentheses here, and there are hydrogens in this H2O over here. So let's look at the left one first. This hydrogen has a 5 after it, so that means there's 5 hydrogens inside these parentheses. But as you can see, there's this little number 2 right after the parentheses, meaning there are 2 sets of parentheses in here. So there's inside the parentheses is C3H5O2. That's in one set of parentheses. But this 2 means there are 2 sets of parentheses. So if we have 5 hydrogens in one set of parentheses and 5 hydrogens in the second set of parentheses, that means there's a total of 10 hydrogens. But now we're not done, because now we have to go to the H2O over here on the right, and hydrogen has a little 2 right after it, so that means there's 2 hydrogens in H2O. But then it also has this big number 2 in front of it, which means there's 2 H2Os. So if there are 2 hydrogens in one H2O, but we have 2 H2Os, then that means there's going to be a total of 4 hydrogens. So we have an H2O that makes 2 hydrogens, but we have 2 H2Os total. 2 H2Os. So if we add those together, we get 2 H's plus 2 H's is 4 H's. So now we have 10 H's over here and 4 H's over here. So if you add those together, you're going to get 14 H's. So we're going to have 14 H's over here on the in the after picture. Now one more, we have to do our oxygens. So we have oxygens over here, oxygens over there. Now let's go in the before picture first, the before side. And here are some oxygens right here. And as you can see, there are 2 oxygens in this little molecule. But how many molecules of it are there? There's 2 of them. So there are 2 oxygens in this molecule, but there are 2 total molecules. So that means there's an O2 plus another O2. So that's going to give you 4 oxygens. And then there's more oxygens over here where it says OH, and then the O is in parentheses, and the little 2 is after the parentheses. So that is going to make it 2 oxygens total. So now we have 2 oxygens. So if we add the 4 oxygens plus the 2 oxygens, we're going to get 6 oxygens. So that means oxygen has 6 over here on the left. Now let's look at the oxygens on the right. Now there are some oxygens over here, and as you can see, this little number 2 comes right after the oxygen. So that means there's 2 oxygens in this molecule in the parentheses. But outside the parentheses, there's another little 2. So that means there's 2 total sets of parentheses. So C3H5O2 is one thing in this parentheses. C3H5O2. And then there's two of them. So there's a second set of C3H5O2s. So if we want to find out how many total oxygens there are, we have to add these together. 2 oxygens plus 2 oxygens is 4 oxygens. But we're not done because we have to go over here and look at these oxygens as well, because we're doing the total amount of oxygens for the entire after the yield arrow, this entire right side. So there's 1 oxygen in H2O. There's no little number after that, so we assume there's 1. But if you look, there's a total of 2 H2Os. So there's 2 H2Os. So if we add the 1 oxygen plus the 1 oxygen, we're going to get a total of 2 oxygens. So now we have 2 oxygens in those H2Os, and we had 4 oxygens up here in this set of parentheses. So if we just add these together, we end up with 6. And as you can see, these are already balanced because there's 6 carbons over here, 6 carbons over here. 1 magnesium on the left, 1 magnesium on the right. 14 hydrogens in the before, 14 hydrogens in the after, and 6 oxygens in the before, 6 oxygens in the after. I gave you an equation that was already balanced, so we could just concentrate on counting the number of elements or atoms of the elements that are on each side of this yield arrow in the before and after. So I hope that makes sense. So just remember, if you have a big number at the beginning, then you end up with, something after it. This big number at the beginning applies to this whole thing. These little bitty numbers applies to whatever just comes right before it. So if it's the little bitty number after of parentheses, it applies to everything inside the parentheses.